Okay, I'm now going to show you how to get the data we've just stripped from the DXF onto an Autopilot file. First of all, we open the Virgin Field Rover demo and we create a new job. Now, you can work out your own ways of doing things, but I normally name the job from what we're paving and what changes we're paving from and to. So this was SWC 291,690 to 291,842. Then it automatically asks you if you want to be in metric or imperial. Once you've selected metric, it should stay as default. Okay, so we've started a new job. Now we need to put the DXF into this Virgin file. So you don't have to close this down, but if you go and copy wherever you stored your DXF with just the string lines we require on, I've got it stored in my documents. If I copy it, then in Windows Explorer still go to the Virgin Field Rover tab. That's actually in your programs or C drive, I think. It's on your C drive. Then click on data, always in the data folder, and then the list of the jobs, the Autopilot jobs, comes up. You need to find the one you've just created. So I call that SWC 291,690 to 291,842. I've got a lot of jobs here. Really, I should delete most of them because they're from quite a while ago. So open up the job. Now, once you've opened up the folder, this is where you paste the DXF into. So I've copied the DXF that we stripped down before. Now we'll just paste it straight into the Autopilot job. That's it. You can close that window down now. So now we're back on the Autopilot Field Rover simulator. If you click on the globe in the top right hand corner, this is the part of the software where you import any drawing. To import, it's quite simple. You go to File, DXF, Import DXF. Then it'll give you a list of all the DXF drawings that are already in the Autopilot job. So that was the one we copied and pasted into the job. I double click that and the DXF is imported into Autopilot. Now Autopilot works in this funny way where it works with shapes, not lines. So you have to convert any of the polylines that were in the DXF file into Autopilot shapes. So if I zoom in on the two lines either side of the SWC, you go to Tools, Polyline to Shape. It says select polyline. I'll click on the barrier side of the channel. Then you're converting that polyline into an Autopilot shape. You have to give it a name. So I would say SWC. Sometimes these names get quite long. 291,690 to 291,842, and that was the northbound side of the channel, so I'll put an NB after it. I've got to change the other polyline to a shape, so go Tools, Polyline to Shape, click on the other polyline, and I will give it the same name apart from I will put southbound after it. When you're paving, you'll only ever use one string line to pave with, but if I only gave you one side of the channel and then you decided to pave in a different direction, you could end up paving quite wrong. It's good, in my eyes, it's good to have both sides of the channel, so when you're on site it's more clear which that you pave into the correct line. So if I click on that bottom left hand corner, it's zoom extents. You can see both the lines have been converted to shapes. So now you can get rid of this feature in Autopilot is where you do all the editing, where you import the lines, like I said, and it's quite a powerful program. You can do other things with it, but I'm not going to show you how to do them. So now, so I escape out of there. Now, just as a sanity check, you can check those shapes that you've imported. If I go to Edit, Draw Profile, and then you choose, they're the two shapes either side of the channel. That's the northbound side. If you choose one of those, that will display the vertical profile. Now, we've kind of got lucky a bit here, because it's always worth checking, because now and again you'll get a design that's got an error in it somewhere, and it might have a huge spike or drop somewhere along the line. That looks okay. It looks a bit funny at the start in this area. I don't know why. That looks a bit severe for a real road design. So that's why you should. It's very rare that you'll come up with something that doesn't look right, but that's why it's good practice to check it. So if I check the southbound line, you see that one looks okay. So that leads me to think that there's a bit of an error in the design in the northbound side, or that might be just the part of the line that I extended in the last video. So those two lines are now on the Autopilot file, ready to put station. Now all we need to do is add the station coordinates, which I will show you in the next video. You can see the horizontal alignment. If you click on Draw Center Line, click on which line you want to look at, and it's just a plan view, but it gives you the length. It's a check to make sure that everything looks right. The length down here, it will tell you the start and end chainage of that individual line. So the start chainage is 0, the end chainage is 169.930 meters, which pretty much works out with the chainages. Okay, what else can I show you? If you go to the profile editor, this will show you the difference in elevation between the turning points, the tangent points. So at chainage 0, your elevation is 40.978, chainage 10, your elevation is 40.918. So that shows that the channel is going downhill by 60 mil over 10 meters. And then you can cursor through. Cursor through here. Yep. Okay, yeah, sorry. You can cursor through and you can inspect your vertical profile. You can also inspect your horizontal profile on this one. It tells you the length of each segment. It's generally they're split into 10 meters, but you sometimes have the odd random smaller section. And that'll do for now. What I'll do now is then we'll finish this video and I'll make another video of how to input station coordinates. Okay, see you in a bit.